Hi guys, so we are going to be going over the remainder and factor theorem again. We went over this during our Zoom meeting. So for this video right here, what I want you guys to do is take out a piece of paper because this is what you're actually going to be submitting as well as your assignment. So what I'm going to be doing is I'm going to be doing half of the problems for you. So you want to make sure hold on. All right, so you want to make sure that you are writing everything down because you are going to be submitting this. So if you don't write anything down, then you pretty much are going to have to redo all of this again. So make sure you have a paper out, title it like this, and then that paper you're going to take a picture and then you're going to submit it. So what I'm going to be doing is I'm going to be working on the odd problems and you're going to be working on the even problems. Okay, so let's go ahead and get started with the first odd problem, number 1. Okay, so in here it says evaluate each function at the given value. So one way we can do this is by plugging in -3 into there. Okay, I could do that, but I don't want to do that because we learned a new method of how to do this. We use synthetic division. If I were to do all of this, that would take me a long time. So what I'm going to do is I'm going to use synthetic division for this. So I'm going to list all my coefficients. It's 1, -2, -18, and -3. And then the number we're going to put there is going to be -3. Now I'm going to go ahead and use synthetic division. Now why do you want to do that? Because the factor theorem, or the, what is it called, let me just pull it up here, the remainder theorem says that whatever you get in there, that's going to be the answer for this right there, which is great. Okay, the remainder theorem, by the way, it's on page 372 in case you want to look at that. So in here all we have to do is, like, we already learned this from our Zoom meeting. We bring this one down. The -3 times 1 will be -3, and then -2 plus -3 will be -5. Then -3 times -5 will be 15. Then -18 plus 15 will be -3. And then finally -3 times -3 will be 9. -3 plus 9 will then be 6. So in here what we actually get is 6. If I would have done all this math, I would have gotten 6. Okay, so as you can see, I feel like the synthetic division is a lot faster than having to plug those numbers in there and getting the answer. Alright, so that is that one for there. So make sure you wrote that down on a piece of paper. Now what you're gonna do is, I want you to pause the video and actually do number 2 below that. So that way, when we are done with this video, and when you're done with this video, you are done with the whole assignment. So make sure that you do number 2. The answer for number 2 is actually -3. Okay, so -3. I want to see your work for that one. Okay. All right, let's do this one here, number 3. All right, so I'm going to do this one for you as well. I'm going to list all the coefficients. We have -2, 13, -17, and 14. We don't actually missing any of those. All the powers are there. And then in here I'm gonna put the 5. Alright, so now I'm gonna go ahead and bring this one down. We're gonna bring the -2 down. 5 times -2 is -10. 13 plus -10 is +3. 5 times 3, okay, 5 times 3, that will be 15. Negative 17 plus 15 will be negative 2. Now 5 times negative 2, that will be negative 10. My final answer will be 14 plus negative 10, that will be 4. So in here, if I want to find the answer, I could write it like this: f of 5 will equal 4. That is by using synthetic division. Okay? Alright, so now what I want you to do is I want you to work on number 4. Okay? So make sure you work on number 4. That way when you are done with this, you're done. So make sure you pause the video, work on that, and then let's move on. Alright. On the homework, you're also going to find this problem here. It says write a polynomial function of a least degree with integral coefficients that have the given zeros. So what they mean by given zeros is this we also call roots. Now what are roots? Here's what's happening in this problem, guys. What is happening is that we have been given the solution to a polynomial, or the solutions. So this is kind of like the answer, and what you're actually trying to get, it's the question. Let me explain a little bit more. So if those are the roots, if those are the solutions, okay, then you want to find a polynomial that when you solve it, you get those same solutions. Here's how we do it. First of all, let each one of those equal each one of those. So x is equal to 4, x is equal to negative half. Let me actually rewrite this one. Okay, those are solutions. Those are called roots, and they're solutions as well. Alright, so here's what I'm going to do. I'm going to I want this side, and this side to equal to 0. And here's how I'm going to be able to do that. On the first one, I'm actually going to add 2 on both sides. And you're going to see in a second why you want to do that. So this and this cancels, and on this one we're going to get x plus 2. We can't combine those two. We'll get 0. Guess what, guys? This right here is a factor. And we are going to use that in a little bit to find the factors. On this one, we're going to subtract 4 on both sides. So that this and this cancels, and we get x minus 4 is equal to 0. Now this is another factor. Now on the next one, we have to do a little bit more work, and we have to be a little bit extra careful because we're dealing with a fraction. Okay, so here's what you have to do when you're dealing with a fraction. First of all, to get rid of the fraction, what we're going to do is multiply both sides by 2 in such way that you're going to get 2x is equal to, well, this and this cancels and you get negative 1. Now what I'm going to do is add 1 on both sides. So now we're going to get 2x plus 1 is equal to 0. Alright, so here's my factor 1 and factor 2. First factor, second factor, and third factor. I'm going to put all of this together. Here's my polynomial, and this is how it's going to look. The first factor is going to be x plus 2. I'm getting this from this right here. The next factor is going to be x minus 4. And then finally, my last factor is going to be 2x plus 1. Now what the book wants, and essentially what the book wants, is that you multiply all that out. Now I don't personally feel that multiplying all that out it's gonna do much. So for me, and for the homework, and even for the exam, if you give me this right here, that's all I want. Okay? Now, on the book, it might ask you to, it might give you the answer like this. And I'm gonna write it down. 2x to the third minus 3x to the second minus 18x minus 8. Where is this coming from? Well, that comes from multiplying all that out. So it's not that difficult to do, but it's just very annoying to do. Like for example, this one here, I could multiply, it's gonna be x squared. We have 2x minus 4x, it's gonna be negative 2x minus 8. You can kind of see where this is all coming from. Then we have 2x times x squared gives you this right here. So you get 2x to the third, and then, you know, if you were to multiply all that out, which to me, it's a very annoying process to do. So I always tell students, hey, you know what? Just leave your answer just like this, and I'll be happy with that. Okay? All right, so let's go ahead and there's people emailing me. All right, so number 7. Okay, we're gonna do the same process here. We're gonna let x equal, actually, never mind guys. I want you guys to try number 6. That's what I wanted you guys to do. So go ahead and do number 6 and then move on. Just got distracted with that email. All right, number 7. Hopefully you paused the video for 6 and then you did number 7. So for 6, it was this. If you haven't paused the video, pause the video and work on that one there. All right, number 7. Let's talk about this one here. So we want x to equal negative 1 over 5. We want x to equal square root of 3. And we want x to equal negative square root of 3. Okay? So fractions, again, to get rid of that fraction, what I'm going to do is multiply it times 5. So that I get 5x is equal to negative 1. Bring the negative 1 over and you get 5x plus 1 is equal to 0. This right here is one of my factors. On the next one here, what I'm going to do, and it's very simple, is I'm actually going to square both sides. So square that, and the square this right here. What that's gonna do is, well, that's gonna get rid of the square root. So I'm gonna end up getting square root of 3. Square root of 3 to the second power is actually 3. The root is then going to be x minus 3 is equal to 0. All right, that's the same process is actually going to follow on this one here. Because I'm actually going to get x squared. We're going to square this and I'm going to put it on parentheses. You know how when you solve quadratics, you always get plus or minus? This is what's happening in here. Actually, this was supposed to be an x squared. And in here, negative 1 to the second power is also 1. So we actually get the same thing. Now, we have to be extra careful in here because you don't want to put both of those. You're going to notice that this one and this one, they cover this and it covers this as well. They're the same thing. So in this case, we don't have to write it down. We don't have to write both of them down. They're the same. So we're going to write 5x plus 1 times x squared minus 3. This one is not too hard to multiply down, so I'm just going to do it. So we have 5x times x squared is going to be 5x to the third minus 15x plus x squared. I'm just using the FOIL method to just multiply everything out. Let's organize it in a way that it makes more sense. It's 5x to the third plus x squared. I always like to put the powers correctly. Okay, and there it is, guys. That'll be the solution for number 7. Alright, so I want you guys to try number 8. Number 8 is the same idea, but just with different numbers. Alright. Let's go ahead and do number 9. Hopefully you tried the other one there. Alright, so this one here is saying that there is a multiple of negative I. So what that means is that I'm actually need to do this twice. So it's like this. X is equal to negative I and x is equal to negative I. I need to do it twice. That's what they mean by multiple of 2. It means that it just happens twice. That solution occurs twice. Here's what I need to do to get rid of that I, though. I need to square both sides. And what happens when I do that? So I'm going to get x squared in here. Well, negative square is going to be 1. Negative 1 squared is 1. But I squared, that becomes a negative 1. Bring that negative 1 over to the one side, and this is what you get. And this is pretty much the same process. So now the polynomial that you get from this will be x squared plus 1 times x squared plus 1. I'm actually going to multiply this one out as well because it's easy and I want you guys to see that. X squared times x squared is going to be x to the 4. Then we have x squared plus x squared plus 1. Add those two together. Our final answer should be this right here. All right, go ahead and do number 10. All right, so the next ones I'm just gonna do it a little bit faster now. This one is x to the x is equal to 5. This one is x to square root of 2. This one we just bring the 5 over and we get that. This one we have to be extra careful. We want to get rid of that radical right there. So the way you do that is by squaring both sides, so that you get x squared is equal to, and when you square this is what you get. So it's 2 times the square root of 2 times 2 times the square root of 2. Well, 2 times 2 is 4. And then square root of 2 times the square root of 2 is 2. So 4 times 2 will be actually 8. Bring that 8 over, and then your polynomial is going to look like this. X minus 5 times x squared minus 8. If you were to multiply that out, I'm looking at my notes here. If you were to multiply that out, you will get x to the third minus 5x squared minus 8x plus 40. Okay, go ahead and do number 12. Okay, so let's do the last one here. X is equal to 1 over 4. X is equal to square root of 2. And then this one here, I'm not actually going to do because I know that that's just an extra one. First of all, multiply times 4 on both sides, and then you get 4x minus 1 is equal to 0 for one of them. Square both sides on this one here. X squared is equal to 2. Then we have x squared minus 2 is equal to 0. Then the polynomial is going to be the following. 4x minus 1 times x squared minus 2. If you were to multiply that out, this is what you will get. You will get 4x to the third minus x squared minus 8x plus 2. Alright, so that is how we find polynomials out of roots or out of solutions. Okay? So I'll let you finish number 14 and you should be done with this assignment.